viewers to another episode on ASUG 12 exams. So in this episode we continue looking at the 2019 August paper. So this is basically the GCE paper. So we are starting to look at section B, which carries 45 marks, and there are 9 questions which are compulsory. Let us move straight into question B1. So B1 reads, figure B1.1 shows a displacement time graph for the motion of a dog over a period of 12 seconds. Use the graph to calculate Roman numeral 1, the velocity of the dog at 10 seconds. So velocity, basically velocity is given by displacement over time. So at 10 seconds the displacement is basically 40. So 40 meters divided by what's the time? So the time is basically 10 seconds. So 10, we end up with 4 meters per second. So 4 meters per second basically is the velocity at time 10 seconds. We move to Roman numeral 2 of M. Calculate. So basically we are using the graph to calculate the acceleration of the dog from 0 to 10 seconds. So let me just use this space. So this is basically Roman numeral 2. So acceleration is given by final velocity minus initial velocity over time. So since we're starting from 0, the initial velocity is 0. Then at 10 seconds we just found the velocity to be 4 meters per second. So we are going to substitute. So it will be 4 meters per second minus 0, which is from left, then divide by time. So the time is basically in 10 seconds. So it will be between, basically, remember this is 0 displacement, divided by time, it will just be 0 velocity because starting from left. Then final velocity is 4 meters per second, like we've done. Then time is the difference between these two, which is 10 minus 0, which is 10. So we divide by 10, we are going to end up 10 minus 0, we are going to end up with 4 over 10, which is basically 0.4 meters per second square as our acceleration. Then let us look at B. So B is, from the graph, determine the time when the dog is not moving. So when the dog is not moving, what will happen is basically displacement will not be changing. So there is no distance covered. So there is no change in the direction of position. So that period happens from here. So it's from here to here. It's this region. So basically the time is basically between 10 and 12 minutes. So to find, so basically what we are going to do here in this case is basically 12 seconds minus 10 seconds, which gives us basically 2 seconds. So 2 seconds is basically the time when the dog is not moving, which is between 12 and 10 seconds. So you see the total time is to be 2 seconds within that interval. So basically this is how you get the 5 marks from this question. Let us look at question B2. Figure B2.1 is a uniform plank of length 100 cm kept in equilibrium by a 3 kg and 1 kg mass, placed 10 cm and 20 cm from each end respectively. Question A, calculate Roman numeral 1, moment of the 3 kg mass. So we know that a moment is given by force times distance. This distance, perpendicular distance in meters. So what we need to do is we need to find the force acting on 3 kg, which is basically a weight, which is equal to a mass times a gravity. So what we have is basically 3 kg multiplied by 10, which is gravitational force. We have basically 30 Newton. So 30 Newton is the weight acting on the 3 kg weight. Then next, we need to find the perpendicular distance, which is d. Now this d should be in meters. So from the pivot, so this is the pivot, then we have 20 centimeter. So 20 centimeter need to be converted to meters. So if in 1 meter we have 100 centimeters, how many meters are in 20 centimeter? So it's 20 centimeter divided by 100, which is 0.2 meters. So hence we have moment is equal to 30 Newton multiplied by 0.2 meters. Then we end up with 6 Newton meters as the moment of the 3 kg mass. We move to Roman numeral 2 of A, weight of the plank. So the weight of the plank will apply the principle that the clockwise moments must be equal to the anticlockwise moment. So what this tells us is basically F1 times distance 1 must equal to F2 times distance 2. So now we are going to add all the moments to the right hand side and also add all the moments to the left hand side of the pivot. So now, since we are calculating the weight of the plank, we need to find the center of the plank, the center of mass. Where will the weight be concentrated? So it will be concentrated at halfway, because this is a uniform plank. So the halfway is 50 centimeter because this is 100 centimeter. So we have 20. This is 20, then and this is 30. So 30 from 30 basically. From 50 we take out 30, we remain with 20. So meaning it will be somewhere here in such a way that this is 20, then this is 30. So this is where the weight of the plank will be. Then remember, this moment we've already found it to be basically this side is just 6 Newton meter. So what this tells me is basically from this one we proceed to here. We have basically 6 Newton meter, which we've already found must equal to, which is all the moment to this side, the left hand side of the pivot must equal to. Then what's the weight acting on 1 kg? So the weight acting on 1 kg basically will be basically mass times gravity, which is 1 kg times 10. It will just be basically 10 Newton. So we have that, which is 10 Newton multiplied by the distance to convert it to a moment from the pivot, which is this side, which is 50 centimeter. So similarly, like we did on this one, we convert that to meters by dividing by 100. So we have a 0.5 meter. Then plus, now the weight of the plank. Since the plank, the weight is to the right hand side, so we need to find the moment of this weight of the plank. If it was the left hand side, we are going to basically add it to this side, but you see to the right hand side of the pivot, so it needs to be added to the other side, so that all the moments from the right hand side are added. Then we equate them to the one to the left hand side. So basically we have from the pivot, this is basically 20 centimeter. Then let us say, since we don't know the weight, we shall just call it W multiplied by the distance from the pivot in meters, which is 0.2 meters. Remember the 20 centimeter we found the middle here. Then simplifying that, we have 6. So since they are all in Newton meters, let us just subtract the numbers. So what we have is basically 6 Newton meter. So 6 Newton meter is equal to this times that is 5 Newton meter plus basically 2 weight. So weight is in newtons, but distance is in meter. So basically what we have now is 6 Newton meter. Once this one crosses the equal sign, it becomes a negative, so we have 5 Newton meter is equal to basically 0.W meter. Remember, W is in meters, then weight is Newton meter, so it's Newton meter also. So what this tells us, we have 1 Newton meter is equal to 0.2 W Newton meter. These newtons and this one cancel, so it's just the same as 1 is equal to 0.2 W. Then we divide by 0.2 to find W, which is weight. Then you're going to have 5 Newton, because weight is Newton, is equal to W. So the weight of the plank is basically equal to 5 Newton as the weight, 5 Newton. So basically this is how you answer this question. Then B, state one application of the above setup. So the above setup has got a number of applications. So what you need to understand is basically how is this. So basically what you notice here is the pivot is at the middle. Okay, then this side you can say this is basically the effort, then this is the load. So you discover that the one which works like that is the first case. We have basically a scissors, okay, which is a pair of scissors. Okay, a pair of scissors works like that. Number 2, we can also use it for wheelbarrow. Remember, the pivot of the wheelbarrow is at the middle, so wheelbarrow can be used for a wheelbarrow. Okay, then also I think you can use it for the case of closing the door where the hinge is somewhere there. But these two are the classical examples that you can use. So basically this is how you get the 5 marks on this question. Let us look at question B3. Figure B3.1 is a diagram of a spring catapult designed by a pupil for science project. The catapult consists of a movable plunger with a spring attached to it. A metal ball of mass 0.2 kg was placed on the metal plate, and the handle of the catapult pulled to fully compress the spring. On release of the handle, the ball was projected 1.5 meters vertically. Name the type of energy stored in a compressed spring. So a compressed spring basically will have a potential energy. So this is potential energy, which will start to be converted to kinetic energy once the spring is released. Then question B, calculate the maximum potential energy acquired by the ball from the catapult. So B, potential energy is given by mass times gravity times height. So what's the mass? The mass of the ball is 0.2 kg. Then the gravity is 10 newtons per kg. Then the height is 1.5. So we just say 0.2 multiplied by 10, then multiplied by basically 1.5. Remember, this is the force, mass times gravity. So the force is basically 0.2 times 10, which is basically 2 newtons as force. So these 2 newtons, we multiply it by the height, which is 1.5 meters. You are going to end up with 3 joules as potential energy. That's B. Then C, give one reason why potential energy you have calculated in B is less than the original stored energy of the spring. So basically what you notice here in this case basically some of the energy as you release the spring will be converted into other forms, so it will be lost, because one, as you release the spring, what will happen is basically the spring will start vibrating. So as you release the spring, so as it vibrates, it's creating some basically sound energy. So some of the energy will be lost through this vibration. So not all of the energy will be transferred into kinetic energy, which will result into that potential energy reached by the highest height of 1.5 meter. Then secondly, there will also be friction. So some of the energy will be lost through it from basically as the friction happens. So as they are shaking, there will be some small amount of heat energy that will be lost through friction between the ball as you compress it, and the spring. So because of this, basically we discover that not all the stored potential energy in this spring will be converted to the potential energy. So the original stored energy will not necessarily be all of it converted to potential energy. So basically that's the possible ways you can lose this stored energy in the spring. So basically this is how you answer this question to get the 5 marks. Let us look at question B4. Figure B4.1 is a diagram of a block and a tackle pulley system used to lift a load of 200 kg. State the velocity ratio of the pulley system in figure B4.1. So basically the velocity ratio in a pulley system is basically equal to the number of wheels in the pulley. So in this case we are just going to count basically the number of wheels. They are 1, so we have 1, then 2, then 3, 4, 5. So in this case velocity ratio is basically equal to 5. So note, when you're dealing with the pulley system, the number of wheels in the pulley system is basically equal to a velocity ratio. B, if the machine has an efficiency of 80%, calculate the effort applied. So basically we're given the efficiency, so we're asked to find the effort applied. So basically we know that efficiency is equal to basically mechanical advantage divided by velocity ratio. Then basically this we multiply by 100%. Then from what we know is, we know the velocity ratio to be 5. Then we know basically the efficiency. So the efficiency is basically 80% is equal to mechanical advantage, which we don't know, over basically velocity ratio, which is basically 5 multiplied by 100%. Then we divide by 100 both sides, 100%, and this side by 100%. So remaining 0.8 is equal to mechanical advantage over 5. Then we basically just cross multiply. Remember, this 100 and this 100 cancels. So what we have is 5 times 0.8, which is basically 4, is equal to 1 times mechanical advantage is equal to mechanical advantage. So mechanical advantage is equal to basically 4. Now we know that mechanical advantage is given by the load over effort. So we need to find effort, since the load is 200 kg. So basically we can just use in kg, because they are all multiplied by the gravitational force to field to convert to force, so it will not have any impact. So we know what mechanical advantage is a form. We know what the load is 200 kg. So you can find effort easily by saying 4 is equal to basically the load is basically the load is basically 200 kg, then we divide by effort E, then we cross multiply, we get basically 4 effort for E is equal to 200 kg, then we divide by 4, so effort basically will equal to 50 kg. So 50 kg is basically the effort, which will be here. So since the load is in kg, we also give effort in kg. If the load was in newtons, we are going to give effort in newtons. Let us look at question B5. Figure B5.1 is a graph of how a wave is propagated. From the graph, determine the amplitude of the wave. So the first thing that we need to ask ourselves is, what is an amplitude? So an amplitude basically refers to the maximum displacement of the particle from its rest position. So what is the rest position in this case? So the rest position is basically along this line. So this is the line which has the rest position. So now the maximum displacement is basically at these points, okay, from the rest position. So this is basically the amplitude. So to find the amplitude, we need to know how we are measuring the height. So this one basically we have these are in meters, so we have 5 meters, 10 meters, this is 15 meters. So 15 meters in this case is basically the maximum displacement from the rest position, or the distance between the rest position and the crest, and this is basically the crest of the wave, and this is basically the trough of the wave. So basically that's the amplitude. Let us look at Roman numeral 2 of question A. From the graph to determine the wavelength of the wave. So if you look at this wave, again we ask ourselves is, what is the wavelength? So the wavelength is basically the distance between either two crests, so from here to here, or two troughs from here to here, or from this point to another point. So this point, so this should be complete up and down. So basically if we pick the distance between two crests or two troughs, so it will be from here. So this is basically halfway, and this is another halfway. So what we notice here is basically we are moving from 75 to basically this distance. So from 75 to this distance. If you pick this one, which is much more easier, at this point up to, and this point we'll say this is 60, then this is 120. So what we notice here is the wavelength will just be basically 120 centimeter minus 60 centimeter, which is basically give us 60 centimeter. So basically 60 centimeter is the wavelength, which is the same as 0.6 meters. So that's the wave length. Then basically the question B, calculate the frequency of the wave if it travels 3 meters per second. So basically we know that velocity is given by wavelength multiplied by frequency. So we are given the speed, which is this one, 3 meters per second, then wavelength is 0.6 meters. So we can find frequency by dividing by wavelength both sides. So frequency is equal to speed divided by wavelength. Speed is 3 meters per second, then wavelength is 0.6 meters. So we divide by that, what we end up is basically 5s. So 5s is basically the frequency of this wave. So basically This is how you get the 5 marks on this question. Let us look at question B6. Figure B6.1 shows a perspex disc fitted on a wooden stand. When rubbed with air, electrons move from perspex disc to the fare. What charge is induced in the perspex disc? So now what happens is, because electrons are leaving this perspex disk, which was initially neutral charged, then we are going to have more positive than negative, so it's going to remain positively charged. So as electrons leave this disk, it remains positively charged. So what charge is induced in the perspex disk? So it becomes positively charged. So basically that's the charge, which is positively charged. State the unit in which charge is measured. So charge is measured in coulomb as the measure of charge. Small pieces of paper brought near the perspex disk sticks to it. Explain why. Now what is happening is, because this perspex disk is positively charged now, when the paper is brought, this paper is neutral charged. So once it's brought near here, what happens is, because this has more positive than negative, what will happen is this will become negatively charged. So will become negatively charged because it's already neutral. So once it's brought here, it will become negatively charged, because this is more positive than this is neutral. So because of that, these will attract each other. So this will happen through basically conduction of charges. Okay, through conduction of charges. Hence you notice that it will stick to that. So basically, in short, because the perspex disk is positively charged. Okay, because it's positively charged, so what happens is it will do induce a charge on papers which is neutral. So hence you are going to discover that these papers will be induced with an opposite charge. Hence it will be attracted to that, and they will attract each other. Hence this is because it's lighter, it will stick to this one which is heavy. So basically that's what will happen. Let us look at C. When a polythene rod was rubbed with air, it was able to attract small pieces of paper too. Name the type of charge induced in the polythene rod and explain using movement of electrons how charge was induced. So now the polythene and air. So these are basically to understand what is happening here and the movement of electrons, we need to look at what is known as basically dielectric constant. So there is a concept called dielectric constant. So this one basically it basically measures the capability of a material to store electric charge. So now what you notice here is this polythene. as basically two dielectric in terms of the capability to store a charge. Okay, then while the Fe as about 1.3 to 1.7. So the dielectric of the polythene constant is higher than that of a Fe. So now what will happen is basically the polythene, okay, the polythene which has the higher capability to store electric charge, what will happen is basically is going to gain more electrons from Fe instead of electrons moving from the polythene to a Fe. So it's going to get more extra electrons, hence it will become negatively charged, as opposed to what was the case under this perspex disk. So because of what is happening is basically electrons will move from the Fe, which has a lower dielectric constant, to a higher dielectric constant. So hence what is happening in this case, these electrons move from Fe to a polythene. Hence polythene becomes negatively charged. So basically this is what is happening in this case of section C. So please find time to check on this concept, the dielectric constant. It will help you to appreciate more, but basically that's a principle that I've explained. So ideally electrons moves from a material with a higher a lower dielectric constant to a material with a higher capability to store a charge, which is indicated by a higher dielectric constant. So basically this is how you answer this question to get the 5 marks. Let us look at question B7. Figure B7.1 shows a circuit diagram connected to a 12-volt supply. Calculate a combined resistance of 2 ohms and 3 ohms. So if you notice in this case, basically what we have basically this is a series, because if one here is off, basically what will happen is even this one will be off. So to find the combined resistance, so just basically you just add resistor 1 plus resistor 2, which is basically equal to 2 plus 3, which is basically 5 ohms. So 5 ohms is the combined resistance of this circuit before it is closed. We go to B. Calculate the total resistance in the circuit when the switch is closed. So once the switch is closed, we have two scenarios. So we have basically these are now parallel to each other, then this is in the series. So the first thing is we need to find basically resistor for this parallel circuit, then we add it with the other one in series. So let us start with combined resistor in parallel will equal to basically we'll call this one to be R2, resistor 2, resistor 3. So it's resistor 2 multiplied by resistor 3 over resistor 2 plus resistor 3. So this one is basically equal to 3 multiplied by 6 over 3 plus 6. So this is 18 over 9, which is basically equal to 2 ohms. So 2 ohms is basically the resistor across these two parallel resistors. Then the total combined resistor in the circuit will be basically combined resistor in parallel plus this resistor in there, because these two they are making basically the series. So it will be basically 2 ohms plus these 2 ohms. So we end up with basically 4 ohms as the total resistance in this circuit when it is the switch is closed. So this is basically this switch. Let us go to C. The potential difference. Calculate the potential difference across 2 ohm resistor. So it's basically we are talking about across this resistor. So what will be basically actually the potential difference, which is in this case a potential difference. So we know that basically potential difference V is given by current times resistor. So having found the combined resistor, basically what we can do is basically to find a resistor before the switch is closed, because you are not told that the switch is closed. So it's before the switch is closed. So before the switch is closed, the combined resistor is 5 ohms. So if you were told that it's closed, it was going to be specific under C. So we know basically the voltage. So we need to find current. So current will be basically equal to voltage divided by resistor combined before it's closed. So we know current will equal now to the volts is basically 12 volts. Then the combined resistor is 5. So it will just be basically 12 divided by 5, which is basically 2.0, because 5 into 10 is 2, remainder 0. Then we remain with a 2 from 12. Then 5 into 2 is 0.4. So this is the amp. So having found the amp, we can find the voltage. So voltage will just be basically 2.4 times what's the resistor? 2. So we multiply these two, we end up with basically 4.8 volts. So 4.8 volts, it will be the potential difference across 2 ohms resistor before the switch is closed. Then D, the total current flowing in the circuit when the switch is closed. So this is now again very specific. So now the switch is closed. So we know that current is equal to basically voltage divided by resistor. So remember, we've already found resistor, and we know that the voltage is 12. Then the combined resistor when the current is closed, we found it to be 4 ohms from B. Then we can proceed to substitute. So we put 4, then 12 divided by 4, we remain with basically we have 3. So 3 amps is the total current flowing in the circuit when the switch is closed. So basically this is how you get the 8 marks on this question. Let us look at question B8. Figure B8.1 shows a diagram of an ion core electromagnet. State 2 ways in which the strength of an electromagnet in figure B8.1 can be increased. So one way in which we can increase the strength of electromagnet in this case is one by increasing the current. So increasing the current flowing through the circuit. So by increasing the current in the coil. So we need to increase the current that flows through this circuit. Number 2 is basically we need to increase the number by increasing the number of turns in turns of a coil. So this number of turns, we make them a lot. then we can increase basically the strength of electromagnet. Then B, explain why the core of the electromagnet is made of iron instead of steel. So what you notice here in this case is this electromagnet is supposed to be basically a temporal magnet. So because when we use a soft iron instead of steel, so iron soft iron loses all its magnet properties when basically this current coil is switched off. So once we switch off the coil, the iron, so this iron, soft iron, or its magnetic property, which is not the case for steel. So the steel basically will maintain its magnetic to become, steels are used to make a permanent magnet. So that's the reason why we have to go with the soft iron instead of steel. So basically this is how you get these 4 marks as quick as possible. Well, welcome viewers to another episode on ASUG 12 exams. So in this episode we continue looking at the 2019 August Science Paper 1. So this is basically physics. Let us look at question B9. Figure 9.1 shows a decay curve of a random nuclide. Question A, define nuclear fission. So basically we have 2 key concepts. So we have fission and fusion that you need to know. So a fission in this case is basically the splitting. So it is the splitting of heavy. So we have heavy, and so this should be heavy unstable nucleus into 2 lighter. So from heavy divided into 2 lighter nuclei. So when this happens, what you are saying, this is what is known as fission, which we are asked to define their nuclear fission. Then on the other hand, which is not asked here, in case you come across it, you have what is known as nuclear fusion. So this nuclear fusion is now basically the process, okay? So this is the process of 2 light nuclei combining together. Okay, so while they're combining together, then they release vast energy. So in that process of combining, they end up releasing a vast energy. So now you see these are opposite. The fission is the splitting. You get it? Because splitting of the heavy unstable nuclei into 2 lighter nuclei. Then the fusion is basically the combination of 2 lighter nuclei to form 1 nuclear, while releasing vast amount of energy. So one is the splitting, which is the fission. The fusion is the combining of the 2. So please take care of these 2 differences. Make sure that you know these 2. Any of these 2 can come. So I just wanted to emphasize the difference. We look at question B. From the graph, determine the original mass of the nuclide. So the original mass of the nuclide. So you see here, this is the mass per kg, then this is the time per day. So what is happening in this curve is showing the decay of London nuclide. So basically we have 80 at the beginning when time is 0. So this is basically 80 kg in mass. So 80 kg is the original mass of the nuclide. Then Roman numeral 2 of B, quantity of the nuclide that remained after 6 days. So 6 days is basically here time. This is 6 days. Then you come and check here, you read on the graph, this is 10 kg. So that's just 10 kg as the mass that remains after 6 days. Half-life. So at half-life we started with 80. So at half of 80 is 40. So when we remain with 40 kg at what period? So you come here and read down there. What you notice, this is a 2. So basically the half-life there will just be basically 2 days. So 2 days is basically the half-life, 2 days. So basically this is how you get basically the total 4 marks on question 9. Please join me as I look at section C.